PhD in
This call is
CAC
now being recorded.
from Tripura University, MTech, CAC from Tripura University, and MCA from Devi University. She has published more than 12 papers in international journal and conference proceedings. She contributed one data set on single hand gesture of Satria dance with 45,753 images in the UCI machine learning repository. Her research interest includes network security, side channel attack in the Internet of Things, image processing, pattern recognition, and dance gesture recognition. So the floor is open, madam. So you can start your session.
Hello, thank you, sir. Just sharing my slide and not taking more time. Can you see, sir? Hello,
Yes.
sir.
Visible.
Yes, visible, madam.
Yes, I'm starting. So thank you, participant, for your patience level. So I will introduce, today I will discuss about the Weka, that is machine learning tool. I'm not going, shortly I will discuss. And before going to the Weka or machine learning tool, you have to know about actually the prerequisite knowledge. You want to know what is machine learning. I think that most of the you know about the machine learning. If you have no knowledge about machine learning, then please go through the machine learning, then this tool will be the very beneficial for you. And for this tool, using this tool, there is no requirement of the coding purpose. You just have the, if you have the just knowledge about the classification and clustering, how it is doing, then without coding knowledge, you can experiment your data within this Weka tool. So Weka, through these presentations, I am sure that after this presentation, you will be able to know about what is Weka and how we handle the data set in Weka. And there are basically five applications of Weka that I will show you one applications of Weka. And so with this knowledge, you can apply more for more application. Okay, so today I will discuss about the application of Weka is Explorer, and within this Explorer application, how can you process data, and how can you classify data, and how clustering data, and how this association role mining is working, and how we select the attribute, and how this data visualization work. So in this presentation, I will discuss. First, I want to introduce that Weka. The full form of Weka is Weka 2 Environment for Knowledge Analysis. It is a data mining and machine learning tool developed in the Department of Computer Science, University of Weka, New Zealand. Weka is a collection of machine learning algorithms for data mining tasks specially. Weka is an open source software issued under the GNU, that is General Public License. So you can download the Weka from the website, that is https://cs.weka2.ac.nz. The free versions of the software is already in the free version. From this website, you can easily download, and though there is no so many spaces required for this downloading this application, so it is very user friendly applications, and it supports multiple platforms like Windows, Mac operating system, X, and Linux. Next, Weka manual. If you want to know more about the Weka, then you go through the Weka manual. Weka manual is available in this website. The main features of the Weka is it here 49 data preprocessing tool is available, 76 classification and regression algorithm is available, 8 clustering algorithm, 3 algorithm for finding association rules, and 15 attribute subset evaluator, and with the facility of 10 search algorithm for feature selection. So these are the main features you can find out. This is the main tool of the Weka. It is the Weka interface. The main interface of Weka, you can see here four applications are available. Main GUI, that is graphical user interface, and here the 4 application is Explorer, Experimental, and Knowledge Flow, and Simple here CLI. But in update versions of the Weka, you can also one additional tool is also there. You can see the whole things in a window that is called the workbench window in the latest versions of the Weka. So in Explorer applications, we can pre-process, we can run the pre-processing of data, attribute selection, learning, and visualization of the data. In experimental, testing, evaluating, machine learning algorithm work, and in knowledge flow applications, we can visualize design of KDD process and we can explore the data. And simple CLI, that is, I'm showing, I'm just minimizing my window. I want to show you the Weka interface. This is the main interface of the Weka. Here you can say Explorer, Experimental, Knowledge Flow, Workbench, and Simple CLI. That 5 application is available. Also here from this program, you can log window, means whatever you work in the Weka, you can save in this with the help of this log window. You can use this memory, and you can say you can exit from this window, or you can exit by using this close button. And visualize, you can plot your data set as you want to know, and ROC crowd you can develop, and there are different tools are available, and help window is also there. If you want to know more, you want to explore some things, that you can use this help window. So this is the main GUI interface of the Weka window. Next, now I will discuss about the how we handle the data set in Weka. Okay, the data set, actually the Weka is developed in the programming language using the Java programming language. Here each entry in the dataset is an instance of the Java class, is named as weka.core.instance. Each instance consists of a number of attributes, that is nominal, numeric, string, date, and relational dataset. In nominal, you can predefine the list of values, and in numerical dataset, you use the integer or real number of the value. String enclosed in double quotes, and date and relation. Basically, mainly the Weka is working with ARFF files. That is, ARFF means the attribute relational data format. But you can also use another file format I will discuss. Weka wants to input data in ARFF format. This ARFF format has 2 parts. One is, this is the example of the ARFF format. In this ARFF format, there are 2 parts. One is data sections and one is header section. A upper portion is known as the header section. Here we can see this in the header section. At the rate is sign is there. At the rate, first line is at the rate relations whether. That is, what is your data set? Relations means your data set names. Which data set you want to work. There are so many building data set within the Weka tools itself. So you can see here the relation, that is the you are using the table weather, and the attribute list, that is the column list, will be the outlook. It is the in outlook sunny, it may be sunny, overcast or rainy. Next, temperature is numeric, that is you define this attribute value will be the numeric. And attribute humidity, that is numeric. Attribute windy, that is maybe true or false. Attribute play, that is yes or no. So here you can see in the data sections, in the header sections, you have to declare the attribute and you have to write the name of the data set. And in the data sections, you can see that this first line is sunny. That is, this is the value of the first attribute, outlook. That is, here three option is there, but first data is sunny. And then next value is the temperature value, that is numeric. You define this data set is numeric. So here the numeric value is taken. Next, humidity, numeric. Next, windy data set, true, false, true or false, and play no. So in this way, we can format our data and we can serialize our data for accessing in the Weka tool. So I can demonstrate how this data set is look like. You can also open this data set. First, go to the in browser and you can download the Weka download 3. This is the 3.8.6 version, as 3.9.7 is also available, but it is quite difficult to download. After certain days it will be available in the also. Now this available version 3.8.6 is available in the any browser, and 64-bit you can download from this site. In this way, free download, you can download. So I already downloaded this file. This is Weka 3.8.6, and installation is very easy. You can install. After installation, this is the main GUI window, and here I'm talking about the Explorer. So you go to the Explorer. Before that, I want to show you that how this data set is look like. So I already installed. You just install, and in the C drive program files, you can see here the installed file is there. Weka 3.8.6. Here, one data file is there. From this data file, you can see this data set is already built in the Weka dataset. But you can install your dataset also here in the ARFF format. So this is the ARFF format. Suppose I want to show this data, that is open with here option is not there. You can open with the notepad and you can see the dataset is look like that.
Like that.
Okay. So now I want to discuss what is Weka Explorer. Weka Explorer. So here I already shown that Weka Explorer is this window is like that. Okay. So if you not uploaded the data, then the others buttons are all are disabled. So when you uploaded the data, that is. So what Weka Explorer can do, here the pre-process, classify, cluster, associate, select attribute, and visualize these attributes are present. You can see from here, that is pre-process, classify, cluster, associate, select attribute, visualize. So these are present in Explorer window. Okay. So where pre-processing, what you do by pre-processing window, that is choose and modify the data being acted on. Classify, train and test learning scheme that classify or perform regression. And cluster, learn cluster for the data. Associate, learn association rules for the data. Select attribute, that is select the most relevant attribute in the data. and visualize, view, and interactive to do loads of data. Now, if you upload the data, then how it is look like? Suppose you open file, C drive, already built it. I want to show one data set, that is data, that is iris data or weather data, weather numeric or weather memory. You can see that is humidity, play, outlook on the data set I have mentioned. You can see here this data set. These are the attributes. Here you can see the properties of data, that is relation is weather instances. There are 14 instances, that means 14 row is there, and attribute, that is 5 columns is there, and sum of weight is 14. Here you can see. And in the right side, you can see here name of the attribute is outlook and missing 0. That is, there is no missing value, and distance, there are 3 distance value, because we show that in the data set in outlook value there is sunny, overcast, and rainy. Here 3 values are there. So here see their distance value is 3, and unique means if this value is unique for any column, here unique value is 0. That means there is no unique value in the column, in the row, because the values are merging. So in this way, here you can select the temperature, hot, mild or cool, humidity, that is high or normal, windy, true or false, and play, that is yes or no. So here you can see the graph that is visualized. That for each class there is visualizing graph is here. So in this way you can open the file. Okay. So this window you can from this bird you can load the data, that is open file. If your data is already exist, you can load this file by open file, and if this data is not exist, your data, you can open from URL, you can open from JDBC connections. If you connect, you install Java and you want to connect by JDBC connectivity, then you also can load the data. And this bar is for the filtering, and other things for analyzing the data. Okay. So this is the, you can open in this way, and you can see the attribute. Here iris dataset they are uploaded. That you can also upload it, the iris dataset. Open file. Here iris dataset is there. Open. You can see sepal length, petal length, and width class. So there are so many dataset is available. Which one you want to work, or if you work, you can work with your dataset also. Next, this is the pre-processing part. One important thing in pre-processing part is, that is, you how can you remove, or you can also filter this data set. Pre-processing means, we know that in pre-processing, for our data set, for pre-processing we can some attribute, you can select some attribute, you can remove, so you can choose which filter you want to work. So here if you okay, you can in this way you can filter. Open and then filter and choose here. So you can filter the data by this selecting windows. Okay. So these are the attribute. In this graph you can see this is sepal length, petal length, and class, how this can visualize each of the attribute. Next, you can pre-process. I already show how you pre-process the data. Choose With this bar, you can choose the preprocessing the data or preprocessing, and here the filter option is there. Filters may be unsupervised attribute and instances there. By selecting this attribute or instances, you can modify your data set as you want. Okay, so in this way you can preprocess. Next, how can you classify the data? So how can you classify? I want to show in this data set. There are lots of data sets are for just closing the window. This is sepal length. Okay. Next, classify. In classify, you can see classifier. You can choose which classifier. So you have this knowledge. What are the different classifier is already available in machine learning. So there, so I am showing you the base classifier, how it is work. Then I am choosing base classifier. It's not selecting. Here you can change the value. Process open file, IDs data set, then choose classify. So from here you can use one classifier, base network classifier I am choosing. Then use training set. You can classify in any evaluations method in machine learning. These evaluations methods are available, that you can classify your data by using training set, or you can classify your data by supplying test set, or you can classify data by cross validations and percentage split. There are four options to classify. So here default option is the cross validation in four steps. So four tens means that your data set will be divided into 10 parts, and one will be considered for the testing data set, and others 9 should be considered as training data set. So in this way, uh, 10 times it will go. One will be chosen for the testing data sets, and other 9 will be chosen for the training data set. So cross validation first. So cross validation, 10 cross validation, you can minimize or maximize the fault for this cross validation. I am just using the 10 cross validation and starting. Okay, so this is the result. So from this result section, you can see that your data set, like it is relation IDs, that is you are testing IDs data set. Instances is 150 instances. Here 5 attribute is there: sepal length, petal length, and class. And these are the attributes we are using. And this now also attributes are have the 3 values, and here you can see the result, that is certify the cross validation result, that is correctly classify instances is 139, you can see, and 92%, that is out of 150 instances 139 is correctly classified, and incorrectly classified is 7.33. And these are the some error that which error is shown in machine learning. These errors methods are available, and detailed accuracy by class you can see, that is TP class, FP rate, precision, recall, F measure, MCC, ROC area, PRC area class. So how this is the detailed accuracy of the class. And one confusion matrix is there, and it show the result that here three classes are there, because we this iris data is for three classes, that is whether it is iris setosa or iris versicolor or iris virginica, but your data set will be defined by your class. Here already built data set, that is I am using this iris data set, and here three classes are there. So you can see the in the confusion metric there are three classes. One is A, B, C. So from this confusion matrix, we can see that a number of A classifier, that is iris setosa, it is classified 50, and there is no number in the misclassifier. Here you can say from the second row, that is 44 is in B and 6 is C. That means 50 classes 50 classes will be there in B, but it is misclassified. 6 is supposed to go into the in the B class, but it is shown in the C class. That means that it is misclassified. The values of is the 6. This triangle shows your actual values, and it is the show your the false values. That is in machine learning TP, true positive and false positive is there. So 6 is the false positive value, and for here for C classes that 45 is the true positive value, and B, that is 5 is the false positive value. So in this way we can evaluate the classification algorithm. Here time needed for to build this model is 0 second. That is within 0 second it can build this model. But if you want to write this code, it is so many lines you require, and you have to do hard work for that. So use training set. So we can see that using training set, that is 94%. So before in cross validation it shows that is 92% accuracy, but using this training set we can see that here accuracy is 94%. But always you training set not giving the, so sometimes in training set there may be overfitting problem. So it is better to practice the cross validation evaluation or percentage split. You can see the result of percentage split, that is 94% accuracy. Okay, so here percentage split 66% means 66% is using for training set, and others 44% is using for the testing set. Here you can see the confusion matrix. Here 44 values are there, because for 100% it not showing the confusion matrix. Here 44% for testing set, and only for the testing set this confusion matrix is shown. So in this way we can perform the classifier. So you can choose other classifier also. There are so many classifier, decision tree classifier, and name based classifier, base means classifier, J48 rules, functions, and so many options are there. You can see. Next, I will show you how this clustering is performed. Before clustering, I will want to say something about clustering. This already I have shown the slide. The classification and difference between the classification and clustering is that classification you define the classes, but in clustering you can't define the classes. It will automatically detect the classes. So Weka content cluster finding groups of similar instances in a dataset. We know that clustering means that grouping of the data, grouping of similar data. So here in Weka, it is possible to implement it. K means en, coboem, X means farthest first. So this clustering algorithm is available. Cluster can be visualized and compared to true cluster evaluation based on logly likelihood if cluster scheme produces a probability distribution. So I will show you some demonstration of clustering. You can see when you can preprocess the data. new data, or you can see from the old days data. You can see it is iris data reprocess. You can newly reprocess others data set or clustering. Here instead of since here you don't define the classes, but you can, if you want to define the classes, which class you want to define, then here is one option. That is sepal length will be considered as class, or sepal width considered class, or class will be considered as class. So by default, the classes are not defined, but if you want to define the class, then there is one option for define the class. Okay, so clustering algorithm, I'm choosing one clustering algorithm, that is simple k means. Suppose I'm choosing, and supply test set is not possible here, so percentage please 66%. You can see it is the clustering algorithm. Since here don't define any class, so they already taken that two classes. One is zero class, one is one class. That is 44% of data for testing set, and it shows that in 0 1 class it belongs 29% data, and in 36 that is 71% of data in one class. So these are the cluster error. In the result, you can see this is the relation. These instances, 150 instances, 5 attributes are there, clustering models, and number of iterations 7. How this clustering work, you have to know for machine learning, how clustering is work manually. You know that here you can see this from this result that sepal length is, that is data set, how this clustering is occurred. Okay, so here it is the cluster instances. From these instances in the classification, you saw the from the confusion matrix that how many instances are going to which classes, but here in clustering instances you can see that how many instances going to the which cluster technique. Okay, so in this way, using training set, you can define classes. Suppose petal length, you can start. You can see this is incorrectly classified instances is 33%, or correctly classified instances is 50%. So from this, you can statistically analyze the data, that how your data set is going on, how they clustered and how they classify. Next, here one attribute, here clustering I already discussed. So from this explorer, I already discussed about preprocess, classify and cluster. Next is associate. Okay. So first, what is associate? Actually, associate we use in association mining rules. So association mining means that we generally use in a recommended system, that you are suppose you are purchasing milk and butter from one one shop, and you regularly purchase milk, butter, and or bread or egg. Okay, so these are the association. I'm not going to the details of association mining. You just read this association mining from your own, but I want to show you that this is the table. From this table, we can know about the pattern of. So, in for association mining means we set some rules that which who suppose one customer go to the one shop and purchase milk, and always he or she purchase butter with the milk. Then you have some idea that whenever he purchased butter, he purchased the milk. That it is called the association. In which things associate with which. So in this way, there are in association mining. If you want to learn You can go to the YouTube and you can learn that how association mining is working. So my main motive is that how association mining is working in the Weka. How can you install association mining? So associate you are setting some rule. So for this association mining, so you have to create support and confidence. How it is calculated, you just it is your homework, but I am showing you the how association is working. So in Weka, a priori algorithm is available. So if you want to pre-processing the data, open file, see. For every operation, you have to pre-process the data. You can pre-process the separate data separately. Weka data and iris data, na? Iris data open, and then choose. Uh, it is not possible. People they are for association means all data set will not association rule. You will breast cancer data. Suppose you are loading breast cancer data, open, then associate. Here a priori algorithm is there. For data mining, filtered association, FP growth, a separate algorithm is there. If you see the a priori algorithm, you are selecting a priori algorithm and start, then you will see the result. So if you have knowledge about the a priori algorithm, you can understand the result, that how these rules can be set and how can show this rule. Suppose generate sets of large item, size of sets of large item L1 equal to 6, L1 6, L3 4, L4 equal to 1. So if you know about a priori algorithm, then you can use this Weka dataset for a priori association mining. Next, another modules, that is select attribute is there. Here you can select the attribute. Okay. Suppose in your data set, you just see in your data set there are 10 instances is there. That is 10 attribute is there. But you want to select 5 attribute out of them. Then in which basis you will select this attribute? Which one is important, more important, which one is not important? So how can you select? You can select this attribute by using this select attribute. Okay, here there are options is there, wrapper selections, information gain selections. So if you use, then start, suppose see here, if you using this ranker method, then from this result you can see that these are the attribute rank. This is the attribute ranking, that is 6, 4, 3, 5, that is 0.07, 0.06, 0.05, 0.05, and from here you can see it is this attribute has small value. Suppose iris data, it is unknown data, so you may be not able to understand. I am opening known data. Iris data, open. Okay. Now select attribute. Start. Here in iris data, there is petal length, petal width, and sepal length and sepal width. So these are the 4 attributes. So you can see from this data set, the rank lowest rank is 0.37, that is sepal width. So from your data set, if you want 3 attribute, you don't want to consider this last attribute, then you can remove your attribute from this data set. So how can you remove this data set? You can, from sepal length data, from this attribute list, you can see that is sepal width is the lowest ranking attribute. So from the preprocess, suppose you remove that is sepal width. You want to remove. The remove option is there. So you remove. After this, you test for classify. Start. Here by undo, huh? First, you see how it is classifying cross validation. Start. Your result is correctly instances is 50% and incorrectly instances is uh, 33. Okay, that is 50% correctly instances. Now you remove your data. Remove. Which one is sepal length? Okay, I think sepal will has the sepal length has the smallest ranking. So you remove your attribute and you just apply classification algorithm. First save. Now you use the classification algorithm. Start. The same another data set, weather data set, when from attribute you see the ranking of the weather data set. Here smallest ranking is temperature. So preprocessing temperature you want to remove. Okay. First you see with the temperature classification result. Start. Here correctly classified is 9, that is 64% accuracy. Okay. But after removing preprocessed temperature, you remove and then test it with classify. Start. Has 64%, same result, but in some data set, while you select attribute and the lower ranking attribute, if you want to delete, then there is no difference in result. So from here you can see that if I remove the temperature attribute, then also it shows the same result. That means the temperature attribute has not so much values in the data set. So if you reduce the data set, why we select attribute? Because we select attribute because we want that your data set will be reduced. Because if your data set will be reduced version, then there will be uh, space requirement will be less. So we always select attribute by reducing the lower ranking attribute. Okay, so you can delete this temperature. There will be no difference in the result. So you can easily remove this attribute. So when you create one data set or anything, which attribute will be gives more result and which will be give better accuracy, you can see from this select attribute options. Okay, last option is the visualize the data. That how can you plot the data? Whatever data you are processing, you can from this plot or from this visualized data you can see these things. So I have presented already the attribute selection that can be used for investigated which subset of attribute are the most predictive one. Attributed selections method contains two parts. One is search method, one is evaluations method. You can see that is one is search method in attribute selection. One it is search method, and it is evaluator method. There are two policies there. So attribute selection method contains two parts: a search method. In search method, best for search, forward selection, random, exhaustive, genetic algorithm, and ranking methods are there. And in evaluations method, correlation based, report based, information gain, size square, these options evaluations methods are available in Weka. and it is very flexible. Weka allows almost arbitrary combination of these two. Activity selections demo I have already given you. So how can you select this attribute? I already show in my slide. Information gain attribute I already ranker method I have selected, and this result will be like this. Next, data visualization. Visualization very useful in practice, that is helps to determine difficulty of the learning problem. Weka can visualize single attribute and pairs of attribute. To do rotating 3D visualization, that is XGOV styles, you can use in Weka. Color coded class values, jitter option to deal with the nominal attribute, and zoom in functions. You can use the zooming functions. So how can you use the visualized data? You can see preprocess, open files, iris dataset. You just select pen and then classify, suppose start classify, and then visualize. You want to visualize this data, that is how graph is plotted. So from here you can see in x-axis sepal length is there, in y-axis the class is there, and then here three classes data is available, that is iris cetosha, iris versicolor, and iris virginica. So here blue color is for the iris cetosha, red color is for the iris versicolor, and green color is for the iris virginica. So you can also change your color. Suppose red color you want to change. I think networking problem is there. It's not working. So from here you can choose your color. If you want to choose your color yellow instead of red, then you can choose your color. Select instances, rectangle, polygon. You can use, and here save. You can save your graph here, and x-axis, y-axis. You can change it according to you. So you can visualize the data set in this way. And here is option is jitter option is there. From this jitter option you can visualize more. You can clearly visualize these things. So in this way you can visualize your data. So in my presentation data visualization part, I already demonstrated how it is visualized. After pre-processing data, you can see there are plot size. You can define jitter. By jitter, using this jitter, you can clearly visualize the data. And in this way, you can visualize the data. And there are different graphs there, separately established the graph, and these are the references and resources from where I taken these things. These are resources available. Thank you. And also I want to say that I only discussed the explorer applications of this data. In Weka, there are experimental knowledge flow, workbench, simple CLI. So other application is also there. So in other application, in experimental applications, you can use testing and evaluate your algorithm. And knowledge flow, by using this, you can visualize your data in knowledge KDD process or explorer. In workbench, you can show all the data in one platform and simple CLI, that is you can also commanded this data. Here I use these GUI versions, but in case of in simple CLI, you can use your own command to experiment this data. So in this way, you can data, your experiment your data using Weka tools. Uh, Using Weka tools, you can experiment your data. And if you have more questions, or if you have want to know more, then you can contact and you can mail me in my email ID. And now, if you have any questions, you can discuss with me. Hello.
Participants, any question, please? Any confusion?
So you are so much tired.
So any query from the participant side? I think there is no query, madam.
They are so tired. So okay.
Okay, madam. Then can we conclude the session? And I am
Okay.
also
Okay.
thankful
Thank
to
you.
you for your very informative session.
Okay. Thank you.
So, dear participant,
I am
uh,
leaving. If you have
yeah, yeah.
any query, you can further contact me.
So, dear participant, you can join tomorrow at the same time. That is at the 2 p.m. Alok sir.
Okay, sir, we can conclude today. Participant, let's meet tomorrow at 2 p.m. I'll share the who will be the speaker tomorrow. Thank you. Take care. Bye.